To find the turning points, also known as critical points, of a function, which include maxima and minima, you typically follow these steps. 1. Find the first derivative. Compute the first derivative of the function. The first derivative gives the slope of the tangent to the curve at any point. 2. Set the first derivative to 0. Solve the equation to find the critical points. These points are where the function could have a local maximum, local minimum, or an inflection point. 3. Determine the nature of the critical points. Using second derivative test. Compute the second derivative. Substitute the critical points into the second derivative function. If the value of second derivative is positive, the function has a local minimum at that point. If the value of second derivative is negative, the function has a local maximum at that point. Example. Consider the function f of x equal to x cubed minus 3x squared plus 2. 1. Find the first derivative. F prime x is equal to 3x squared minus 6x. 2. Set the first derivative to 0. 3x squared minus 6x is equal to 0. So, the critical points are at x equals 0 and x equals 2. 3. Determine the nature of the critical points. Finding the second derivative. F double prime x is equal to 6x minus 6. At x equals 0, f double prime x is equal to negative 6, which is less than 0. Therefore, the function has a local maximum at x equals 0. At x equals 2, f double prime x is equal to 6, which is greater than 0. Therefore, the function has a local minimum at x equals 2. This process can be applied to any differentiable function to find its turning points.